Okay, my name is Mr. Wyrick. We're here for the Chapter 2 review for geometry. So we start off with, again, it's lesson 2.1, Inductive Reasoning. You can check those notes from either your own notebook or the ones that have been scanned on. Make a conjecture about the next term. It's a prediction. So this is being multiplied by 3 every single time. 81 times 3 is going to be 243. That'll get us the next term. On this one, it's times a different thing. We can see it go back and forth between positive and negative. So that's times a negative 2. 2 times negative 2 is negative 4. Negative 4 times negative 2 is 8. 8 times negative 2 is negative 16. So the next one should be a positive 32. When we get down here to where it shapes, right, down, left, up, the next one should be facing off to the right, because that's what would come next in the pattern. This one is a triangle, a square, a pentagon. It's 3 sides, 4 sides, 5 sides. So we're just adding 1 side. So the next one should be a hexagon, a 6-sided figure. Make a conjecture about each geometric relationship. Points F, G, and K are collinear. That means they're all on the same line. We don't know how far apart they are. Here's F, here's G, here's K. They could also be in a different order, but this is just our best understanding of it. M, it says, is between F and G. So the only real conjecture that we can make here is that Fm plus Mg is going to equal Fg. The two parts of it are going to make the whole. This is called, I think, the Line-Segment Theorem. We haven't worried about the name of it because it's just, hey, the two pieces of this are going to make the whole thing. X is the midpoint of AB. Again, we've got an understanding of here's A, here's B, 2 points make a line, but this time we know X is dead center of these two things. So we could say a couple things. We can say that AX is equal to XB. All right, we know that those two sides are equal. We could also say the exact same thing. AX plus XB is equal to AB. All right, it's a multiple choice test. So just looking for those things that you know to be true are going to be very important. This last one, it bisects. It's also going to cut that in half. So we're going to have the same kind of things there. The counterexamples. Counterexamples are great also for this stuff on multiple choice. If you can find a way to make it to where it's not true, that's not going to be your answer then. Counterexample for this one, if Mn equals Np, then N is the midpoint of Mp. This is one that we had on an assignment. We could have M here, N here, and P up here, and these can be the same distance, but that N is not the midpoint. It is not halfway between M and P. That wouldn't be a straight line there. If x plus y is less than or equal to 9 and x is 3, then y is less than or equal to 5. Y could be equal to 5.2. And that would only give us 8.2 if x was 3, which would still be less than 9. Okay? We're just looking for that one thing that's going to prove what we've got false. If angle 1 and angle 2 are adjacent, then they form a linear pair. Remember, a linear pair are two angles that are on a straight line like that. So all we have to do is put two that are next to each other, that's what adjacent means, and make them not do that. Here's angle 1, here's angle 2. They're not going to add up to 180. They're not a linear pair. Okay, the conditional statements. The hypothesis is what's after if. That's my hypothesis. The conclusion is what's after then. This is the conclusion. Hypothesis, conclusion, hypothesis, conclusion, hypothesis, conclusion, hypothesis, conclusion. I can't say much more about this, really. other than make sure you know this. There's not any kind of fancy rhyme or anything that works like that. Hypothesis is after the word if, conclusion is after the word then. On the next page, write the following statements in if-then form or as conditional statements. Sue will watch the Rose Bowl if today is January 1st. So this would be if today is January 1st, then Sue will watch the Rose Bowl. Okay? Think about which part of the statement is going to depend on the other part of the statement. That's what's really important here. You get a free personal pizza when you collect 25 coupons. The 25 coupons is the condition that has to be met for you to get a free pizza. So if you collect 25 coupons, then you get a free pizza. A duck's quack will not echo at the Grand Canyon. If it is a duck's quack, then it will not echo at the Grand Canyon. Okay? It can't be the fact that if it doesn't echo at the Grand Canyon, then it's definitely a duck's quack. There might be some other things that don't echo. All right? So you have to think about what depends on the other thing. The truth value. If today is Monday, tomorrow is Wednesday, that's false. Okay? Again, that's what determine the truth value means. Is it true or false? And then tomorrow is Wednesday. Tomorrow is going to be Tuesday. If the absolute value of x is positive, then x is negative. This one's a tough one. We haven't looked at this before, but when you do see this one, the absolute value is the distance from 0. So if we put in the absolute value of -8, we get positive 8. But the absolute value of a positive 8 is also 8. So this is false. The absolute value is almost always positive. If two angles are complementary, then the angles are acute. This one's true. Okay, so converse, inverse, contrapositive. I'll probably only work one example here. Converse, remember, you might write this on here. A converse is where you switch the hypothesis and the conclusion. So this says, if an angle is acute, then its measure is less than 90. The converse is going to be if its measure is less than 90, then the angle is acute. All right? So when we have that converse, we switch the hypothesis and conclusion. The inverse, we are going to add in the word not to both the hypothesis and conclusion. So we go back to our original statement. If an angle is acute, then its measure is less than 90. If an angle is not acute, then its measure is not less than 90. Okay? We have the word not in both parts of this. That's what the inverse does. And then the contrapositive is going to do both of these things. It's going to swap the order, okay? It's going to switch the hypothesis and the conclusion from the original statement, and it's going to also insert the word not. So if its measure is not less than 90, then the angle is not acute. All right? The other thing, and I'll just kind of illustrate this on this one here, is the truth value of these statements. The truth value of these statements always goes in pairs. the original conditional statement and the contrapositive always have the exact same truth value. So if the original one is true, then the contrapositive is also true. If the original one is false, the contrapositive is also false. The converse and inverse are also linked. Okay? They will have the same truth value. If the converse is true, the inverse is true. If the converse is false, the inverse is also false. Lesson 2.4, this is one of those big things. We took the little quiz over it. You are going to have to kind of identify law of detachment. You're going to have to kind of remember what that is. So make sure you look over this. We have that if-then statement. And they always write these examples of this like this, where it's P, then Q. So we have our first part, our if this happens, then this is going to happen. So the law of detachment says what we're going to do is take these two things apart. And if they restate the first one as being true all by itself, the second one is going to be true all by itself. If what they do is state the second one, you can only go in this direction. So you can't just take that effect from our cause and effect and say, well then yeah, the cause is totally true. It doesn't work that way. So this, on number 26, this is our example. If an angle is acute, then it cannot be obtuse. Angle A is acute. So we've got this if statement, we've got a then statement. Okay, we've got our conditional statement. If an angle is acute, then it cannot be obtuse. Then we've got the first part again, all by itself. Angle A is acute, so the conclusion, angle A cannot be obtuse. This is totally valid. This is a great conclusion. It makes sense because it's what we need. If we go to the next example here, all dogs like biscuits. Lulu is a dog. Fluffy likes biscuits. Like, no part of this connects. So this is not a valid conclusion. It could have even, well, if it would have been Lulu here, it would have worked. But Fluffy, I'm guessing, is a completely different dog or a cat or something like this. So this is not valid. It has to tie together. If Mr. Neal goes to work, then he wears a suit. You see Mr. Neal in jeans. Conclusion, he is not at work. We can't say that. Okay? We can't say that because we can't take the second part where he would be wearing a suit and say, oh, this is the cause. All right? He could still be at work. If we just said he's not at work, then we can say, oh yeah, he's not going to wear a suit. But, I mean, you've seen us up here when there's a jeans day. Everybody's going to wear their jeans. Law of syllogism. The law of syllogism is where you have a whole bunch of cause and effects. Again, you'll kind of be expected to put this one together, but you'll see 2 or 3 statements, so you'll know that this is totally going to be law of syllogism. It's if then, if then, if then, and you just cut out the middle. If today is January 1st, then it is New Year's Day. If today is New Year's Day, then school is closed. So we can cut out the middle of this and just say if today is January 1st, then school is closed. We can jump from the beginning to the end. But if you look at number 31, we do have overlap, but it's not overlap that makes sense. It says if Newsom is at school, he's wearing Centennial shirts. If Newsom is wearing Centennial shirts, then he's at a game. So that would say if he's at school, then he's at a game. It doesn't make sense for us to put that together. It's not going to be valid. No valid conclusion. Again, when you see law of detachment, law of syllogism, it's not going to be about the true false, like with the regular conditional statements. It's going to be about, is this a valid conclusion that we can draw from this, Or is there no valid conclusion that we can draw? It looks like in number 31, it's like this guy's always wearing his Centennial shirts, so you can't really say where he is based on that. And the overlap of the places where he is makes it really weird. Okay? This information right here, the addition property, subtraction property, multiplication property, whatever, blah, blah, blah. I made a copy of this, and it's going to be on your answer document for the test. So you will have basically a little cheat sheet there to use when it comes to this part, and you talk about what's going on or how you got from one thing to the next. So on number 32, if 3x equals 6, then x equals 2. The way we need to get there would be to divide both of these by 3, so that's the division property. If 8x plus 4 equals 12, then 8x equals 8. In order to get here, we would need to subtract 4 from both sides. That's the subtraction property. Some of them are going to be a little weird. This one here, number 35, is one that I'd really like to touch on. It says, if A equals B and B equals X, then A equals X. There's a couple of different things that this could be. All right? If you look at the transitive property and the substitution property, which are right next to each other here. If A equals B and B equals C, then A equals C is the transitive. Substitution, if A equals B and A equals 3, then B equals 3. It's really close to the same thing. Now, I haven't sat there and gone over the test with a fine-tooth comb. So if there is a problem like this, and it's multiple choice, and it says it could be, it has options on there for both substitution and transitive, I'm going to count both of them. You don't have to choose both of them, but I count either one. If it's a fill-in-the-blank kind of part to the test where it's like, what's your answer for this? Again, I will accept either one of those transitive or substitution properties because they're super close to the same thing, and I'm not going to try to get nitpicky with you when you clearly can see what's going on. Okay? So this one could be substitution, this one could be transitive. All right? On the end, the proofs, complete the proof. This is not something that we did a whole lot of. We did like one page. So I'll do one, but again, I'm going to scan a completed version of this. I'm going to upload it. And you do have some wiggle room here if you take like more steps or don't go the exact same route. These are all algebraic proofs though. So the first thing is we have 5x minus 3 equals 2. On my other column, the reason for that is it's given. Always start with what you are given. The next thing I'm going to do is I'm going to add 3 to both sides. So for number 2, I'm going to get 5x is equal to 5. Because I added 3 to both sides, that would be the addition property. And then number 3, I'm going to divide both sides by 5. That'll give me x is equal to 1. And the reason I can say that is because of the division property. And this right here is what I was trying to prove, so I'm done with that proof. All right, hopefully this gets you the information that you need. You'll be able to get started. You'll be able to kind of work through some of the rest of these. Again, this video is going to be posted on the Google Classroom. A completed copy of the review will be posted. Make sure you finish up the review. Come in and good luck on the test tomorrow.